Hi, welcome to this lesson on resolving vectors. In this lesson, we'll use an example of a hiker's walk to understand how we can take a two-dimensional vector and break it into its two components. This is the example that we'll work through. We have a hiker walking 10 kilometers at an angle 30 degrees north of east. And the question is to resolve that vector into its component parts. Now what I've done is tried to represent this vector using a vector arrow. I've used a protractor to ensure that I've drawn this vector at an angle of 30 degrees north of east. I'll label that. Here's my angle right here, and that's 30 degrees, and it's north of straight east. And I've used a ruler to represent my vector using a centimeter scale so that every kilometer is 1 centimeter. So I've drawn a 10 centimeter long vector here, and that's my 10 kilometers, 30 degrees north of east. So the process of resolving really means we try and look at, in the case of this vector, if it's traveling north and east, then we want to find out how much it went to the north and how much it went to the east. I have a grid in the background where you can get a sense of how far we've gone to the north and east. You can see that in the east direction it goes that far, represented by that dotted arrow, and it goes to the north a certain amount, represented by this dotted arrow. And technically, if I've drawn a decent enough diagram, I should be able to use my ruler and measure the components and answer the question that how far this hiker traveled to the east and how far the hiker traveled to the north by walking 10 kilometers 30 degrees north of east. So you can see here that in the east direction the hiker's gone about 8.7 kilometers, and in the north direction the hiker's traveled about 4.3 kilometers. Now most people can recognize that that measurement really it's flawed. It'd be much better if we could mathematically determine the amount of the vector going to the east and the amount of the vector going to the north. And that's what we'll do now. We use Pythagorean theorem to determine how far we went in the east direction here and how far we went in the north direction here. Let me start by giving myself a little bit more room to work and show my full solution. So here we have what we call the east component, or the x component. We want to talk about it generically. From math class, I hope you remember that trigonometry will allow us to determine this side of this triangle. So this side of the triangle really is the adjacent side in math language. To calculate for the adjacent side, knowing the hypotenuse, we can use the cos identity. Remember, cos of the angle is equal to, give myself some room here, cos of the angle is equal to the adjacent side over the hypotenuse. So in this case, the cos of 30 degrees should equal our adjacent side divided by the hypotenuse, which we know is 10 kilometers. Solving for this on my calculator, I see that my adjacent side is about 8.66 kilometers. So just like I measured with my ruler, only this time a little more precise because I'm using a calculation. It's not prone to error using my measurement instrument. I find that my hiker has actually traveled 8.66 kilometers. If I want to be precise, it's a vector. I could say that this is in the east direction. In the case of how far they went to the north during their trip, we can use the sine of the angle. It's the opposite side over the hypotenuse. So the sine of 30 is equal to the opposite over 10 kilometers is our hypotenuse. And solving for the opposite side, we find that the opposite side is equal to 5 kilometers. And it's in the north direction. So this is our solution. in the end, after traveling 10 kilometers, 30 degrees north of east, the hikers actually traveled 8.66 kilometers to the east and 5 kilometers to the north. And that's how we resolve vectors. Regardless of what kind of vector it is, we'll see later on that we can resolve velocity vectors, force vectors, all the same thing. When we say resolve a vector, we're really talking about how much is the vector in the x or y component. And that's how we solve and that's the process we use to resolve vectors. We draw the vector, we label it properly, and we use trigonometry to determine what the x and the y component of the vectors are. We can do this with any kind of vector, and later on we'll see how we can resolve velocity vectors, acceleration vectors, and later yet, force vectors. If you have